everyone and welcome to lesson 10 in National 5 Chemistry. What we're going to have a look at today is we're going to continue on with carboxylic acids, but we're going to have a look at neutralization reactions and specifically neutralization reactions involving carboxylic acids. So for neutralization reactions, let's just remind ourselves. So neutralization reactions, we are talking about the reaction of an acid and an alkali. So hopefully I can still remember from school getting it drilled into me that acid plus alkali will create a salt plus water. Okay, I still remember that drilled into me from the school. Now, we've been talking about alkalis as being soluble bases and a base being anything that can neutralise an acid. Now, carboxylic acids are no different. You've been used to our acid here being maybe hydrochloric, sulfuric. Don't be scared when you see that as an F. Sometimes you'll see that as a pH, which is the way we used to spell it, but it changed. Or we might have had nitric acid. And the type of acid that we made always affected the type of salt that we would make in these reactions. So you should know from Unit 1 that hydrochloric acid is going to make something chloride. You should know that sulfuric acid in a neutralization reaction is going to make something sulfate. And you should know that nitric acid is going to make something nitrate. Okay, that is the type of salt, and that's what we mean by the type of salt. And so it's important for us to think, well, what actually, if I used, say, ethanoic acid. So if I used vinegar in my reaction, what is my salt going to be? Still going to be reacting with an alkali, it's still going to be making a salt and water, but what is that salt going to be? So let's have a wee think about maybe a rule in order for us to make these. So let's think of ethanoic acid. So this is the type of acid. And this will be the type of salt. So if I told you, if we have ethanoic acid, that is going to make an ethanoate salt. What about if I had propanoic acid? Well, that's going to make a propanoate salt. So I am taking the type of acids, I am getting rid of the oic acid part, and I am replacing it with OAte. So let's try that with butanoic acid. Give me a wee second to think about that, see if you can do it before I write it down. I'm going to use butanoic acid. I'm going to take off the oic acid part. So that becomes butan. We always take it back to this. This is my parent alkane without the E. We always bring it back to that. But that becomes butanoate. And then we just have to apply this to our word equations that we should already know from Unit 1. So if I just put a box around this, let's think about using ethanoic acid. It's my favourite for some reason. Ethanoic acid plus, let's say, sodium hydroxide. What is that going to make? It's going to make a salt, and it's also going to make water. We like water. So ethanoic acid plus sodium hydroxide makes something plus water. Well, I know my type of salt, ethanoic acid, makes ethanoate. And my rules that we should know from neutralization is we take the first part of the alkali or the base name, so that's sodium, so the metal. And then the type of salt that my acid makes, so that becomes sodium ethanoate. If I use butanoic acid, it would become sodium butanoate as my salt. Always remember to put this in as your full word equation with water though. So that's me using hydroxide. What if I used propanoic acid and we used, this time, lithium oxide? What will my products be? You can have a pause, you can have a think. But propanoic acid plus lithium oxide is going to take the first part of my base, which is the metal, which is lithium, and the type of salt from my acid, propanoate, plus water. It's important. Here's an interesting one. Let's use, I'm just going to use the ones I've got up at the top, butanoic acid plus, let's do calcium carbonate this time. Using the rules from before, take the first part, and then the type of salt that my acid makes, plus water, always remember. However, I have another product. I'm now using a carbonate. There's carbon in this, it's a CO3 group ion. There's no other carbon in here. This is also going to produce carbon dioxide. Be very careful with that. When you see a carbonate, it's going to make carbon dioxide. I always think of carbonated drinks. Think of all the bubbles. The bubbles are carbon dioxide. Okay? Carbonate, carbon dioxide. That's how we go through and name these. And there's a very general way that we can do this, and we can say my carboxylic acid plus metal oxide is going to make something. Carboxylic acid plus metal hydroxide. Think of these as your rules for the word equations. And carboxylic acid plus metal carbonate. The general rules for these, carboxylic acid and metal oxide is going to make my salt, or a metal salt, plus water. Carboxylic acid and metal hydroxide is going to make a salt, or a metal salt, plus water. See, these products are getting very similar. Carboxylic acid plus a metal carbonate is going to make a salt, plus water, plus carbon dioxide. Nice wee summary of those there. The only other one I want you to be very mindful of is, what if it's not metal oxide or a metal hydroxide or a metal carbonate? What if it's a carboxylic acid plus just the metal by itself? What if we're just reacting it with a metal? I'm still going to make that salt, or that metal salt. But now there's not enough in there for me to get water. This has an oxygen, this has an oxygen, this has oxygen in it. That's where the oxygen to make H2O comes from. But that's just the metal, there's no other oxygen in there. So all it's going to make as its second product is hydrogen. So this is one to be careful of. This one is different. It is not salt and water, it's salt and hydrogen. Okay, when it's just the metal. And these are your three when you're using these as bases. Okay, that's all there really is to it. It's just a wee bit of practice. It's looking through questions and taking ones that have different acids with different bases, trying to work out, is it an oxide, a hydroxide, a carbonate, trying to have a think about that and working out what these word equations would be. So in this video, what we've had a look at is that if we have a neutralization reaction, then the salt will end in anoate. So methanoic acid will make a methanoate salt, ethanoic acid makes an ethanoate salt. In all of these reactions, we take the first part of the base with the type of acids in order to form that type of salt to make our salt's name. So our naming salt rules as we do before in Unit 1. We should know that the metal in carboxylic acid will make a metal salt and hydrogen. A metal oxide with carboxylic acid makes a metal salt and water. Metal hydroxide with a carboxylic acid makes a metal salt and water. And that metal carbonate and carboxylic acid will make a metal salt, water, and carbon dioxide. So this is just about the rules for these salts, but what you might find is the naming of the salts using carboxylic acids didn't used to be in the National 5 curriculum. So if you have older textbooks or older questions, it might not come up that often, but it is in there now, so it's worth having a look at and making sure that you can understand how to name them. So that's us for today, and I'm hoping to get another couple of videos done in the near future, so I will see you in the next one.